Okay, so finding a web page that you're interested in, pulling that down into a file that you've converted to a string, editing that file, and then using regular expressions to parse that file apart is an effective and also very difficult way of getting at the contents of a web page. An easier way is to use a higher level web scraping module such as Beautiful Soup. What we do is open a connection to the web page as before, download the web page, but this time build from that a so-called Beautiful Soup object which has the HTML structure of the web page in a nice hierarchical format. We can then convert that Beautiful Soup object into a string, which we can write in a file, and then look at the file to see what interesting HTML tags it has that we can continue using Beautiful Soup to pull out. So the structure of this BSoup1 program is very similar to the Hardscrape program we looked at before. The difference is that we are creating a Beautiful Soup object here by reading the HTML document, and we are then writing that Beautiful Soup object converted to a string into an output file. This time it's Beautiful Soup yield curve temp.txt. Let's run this program. Okay, here is the program. Now there's more to the program down here that for the moment has been commented out using triple quotes. I'm going to save this and run it. And it runs very quickly, and I should have a file named bsyctemp.txt in my directory. Okay, and here I have switched to my Cygwin terminal window, and I can see that yes indeed I do have this bsyctemp.txt file. I can edit that thing with VI like we did before. And I can search for 09 2019. And there it is. All right, and so the structure of what's in here is very similar to what we saw before. All right, so I know the table is in there. I know that it starts with table equals tchart. Let's see how I can use Beautiful Soup now, rather than regular expressions, to pick this thing apart and get the data in my table. Okay, well, the cool thing about the Beautiful Soup object, BSYC in this case, see here's the Beautiful Soup object that we created, BSYC, Beautiful Soup yield curve, is that it is aware of HTML tags. So I can display tables within that Beautiful Soup object by just saying print bsyc.table. Let me cut and move down my string so-called comment here, and let's see what we get when we run this revised program now. Okay, well, this is no shock. We got squeeze text, 1644 lines. That's the same as what we got when we used regular expressions to pull out the table. Let me unsqueeze this and see what we have. I'm going to say OK. And there it is. All right. Okay, so that is actually just the first table in the page. It's not the one that we want. Okay, this is a table way up at the top. It's not the tchart table. So let us find all of the tables, and what we're going to get here is a list of the table tags. So that's the next thing we're going to add into our program. Okay, instead of just printing the first table, what we're going to do is to use find all to get all of the tables that exist as a list, and will display how many tables there are in that all tables list. So let's do that next. And okay, so we're told that there are 8 total table tags. Now each of these tables is very long, and I don't want to just fill my whole screen with the entire contents of all the tables. Here's a trick though. Each of those tables in the BSYC object can be converted to a string, and I can use slicing to see just the first 50 characters of each table instead of the entire contents of each table. So for each table in the table list, let me convert the table to a string and then use a slice to just see the first 50 characters. Let's check that out. So I will once again cut and move my triple quotes down below where I display the first 50 characters from each table. We'll run that. Aha, okay. Now I have something that's easier for me to read. Okay, so here's the first table tag, and actually the first 50 characters following that table tag are spread across 3 lines of output, so that's one table. Here we have another table, the third table, 4, 5, 6, 7, 8. So those are the 8 tables, and only one of these tables has this attribute class set to tchart. Beautiful Soup understands how to look for attribute settings. So rather than just finding all the tables, let me find all the tables in which class is tchart. Now that stuff in curly braces there, that is a dictionary. The key is the name of the attribute, and the value is the string associated with that attribute name. So this should give me back a list of just one table, just the tchart table. So that will be my next test execution. All right, I'm going to move my triple quote comment down below that stuff. All right, so previously I said find all table, and I got 8. Now I'm going to say find all table where the class is tchart, and I'm going to display the length of that list, and there should only be one table in that list of tables. Let's test that. And okay, indeed, there is just one tchart table in that list of tables. All right, now at this point I've realized I'm getting a whole bunch of output that I really no longer care about. So let me comment out some of these print statements earlier on. I don't need this print. And I don't need this print. And I don't need to see this whole loop of the 8 tables. All right, so I'll comment all that out. Let me run that modified program. And there. Okay, so I have one tchart table. Okay, so since there's only one table in that list, I am going to grab that particular table, TC table list sub 0, and now I'm going to loop through all the children of the TC table. Okay, so my document contains 8 tables. I have selected one table. That table in turn contains children, and the children of a table are the rows. So what I want to do is I want to get each child of the table, which is going to be a row from the table, and instead of printing the entire row, let me just convert that row to a string and display the first 50 characters from that row. Okay, so that's the next change I'm going to make. I will move my comment down so that I see the first 50 characters from each child of the TC table, which is to say each row in the TC table. Let's save that and run that. Okay, well, this is not really very interesting. The first 50 characters in each row just tell me this. Well, okay, first I have a header row. TH stands for header, so that's good. So that gives me the date, string. It gives me 1 month. It's going to give me 2 months, 3 months, 6 months, and so on. For all the data rows have these TD tags in them. The rows, for some reason, are marked as either odd rows or even rows. Now, what is that about? Well, let's see if we can actually observe what the distinction is by looking at this website in the browser again. Okay, so I have pulled the website into my browser again, and I'm displaying it, and you may not be able to tell, but I can tell on my screen that every other row is shaded a very light gray. So apparently this odd row versus even row stuff is just used to control that shading. Odd numbered rows are shaded a very light gray in the background. Even numbered rows are white. So I don't really have to pay any attention to this even versus odd row distinction because all I care about is the numbers here, well, the dates and the numbers here. I don't care about the shading stuff. So the children of the TC table are the rows in the TC table. The first child is the header row. Subsequent children are data rows. Let me look now at the children of the children. Okay, now the children of a row are going to be the cell values within the row. All right, so if I look at the children of the table, those are the rows. And if I look at the children of the rows, those are going to be the data values. And let me display the first 50 characters from each one of those data value entries. All right, so that's my next test. I'll move my triple quotes down again. And actually, I'm going to refrain from printing how many T-chart tables there are, and I'm going to refrain from printing out the first 50 characters from each of the rows. So I'll comment all that out, and I'm just going to display the first 50 characters from each data field within the rows. All right. What did I do wrong? Oh, I commented out my creation of the data table itself. That wasn't very smart. So I'll put that back in. Okay, now this looks good. It's a lot of stuff. I'm going to hit Control-C to kill this off. Although, actually, all right, so the output is coming out so fast that even though I press Control-C, it doesn't seem to be wanting to die. So we'll just wait for this to conclude. It's up into September now. There we go. Okay, so here are the data cells in the row describing the interest rates for September 20th, 2019. And as I go up, I'm getting 13 data cells from each row. Okay, the date is the first cell from each row. Then I have the 1 month, 2 month, 3 month, 6 month, 1 year, 2 year, 3 year, 5 year, 7 year, 10 year, 20 year, 30 year interest rates. Cool, so I'm almost there. It's just I need to get rid of all this TD class equals text view data mess. So I've got one more step that I need to perform to just end up with values and not all of this HTML clutter. All right, so I have my table. I have my TC table. The children of the table are the rows. The children of the children are the data cells. And for each of those, I can ask for the contents, which is only going to be either the date in the case of the first cell in each row, or the interest rate value in each of the in each of the 2nd through 13th rows. It turns out these are all going to come out as strings, which is a little bit annoying. And in fact, each one of these is going to be a list of strings, a list of single strings. So I'm not entirely there yet, but I'm really, really close now. All right, so we'll get rid of this print code. And finally, display what I'm really after, which is the values of the cells in the table. Yay! And I'm just going to have to wait. So we're in February. Okay, so we're done. All right. So for each row in the table, what I got is a sequence of 13 one-item lists, or each item in the list is a string. And this I can be a little bit clever about as far as appending these together and converting the interest rates from strings to floats to be able to do analysis and to be able to do plotting and so on and so forth. So that gets me to the conclusion of part 1 of the week 4 lecture. Alrighty.